This is lesson 58 of the Quantum Mechanics, a mini lecture series, Operators, Part 3. So I'm going to do another example with matrix representation of operators. Let's suppose we have an operator A, which acts on the basis states, plus and minus, right? So suppose I have a quantum state plus equal to a half I h bar minus. I've got A acting on the state minus, giving me minus a half I h bar plus. So to express the operator A in terms of a matrix, let's take the plus state to be 0 and the minus state to be 1. Okay. So we can represent A as A plus plus, A plus minus, A minus plus, A minus minus. You can think of this as like A 0, 0, 0, 1, 1, 0, 1, 1. Okay. So to work out the first component, A plus plus, we have to do the following. Okay, rewrite it as follows. Okay, the inner product of plus with A acting on the plus state, which is just this, h bar, right? Because we've defined here as A plus, define A plus as being that. Right, so I've plugged it into here. And that is, so we can take out the half I h bar, okay, it's just a constant, it's a number, left with this. And if you recall from before, these two states here, their inner product is just 0, right? So half I h bar is just 0, times 0 is 0. Similarly, let's do A plus minus, okay? That's just plus A hat minus. Okay, plus A hat acting on the minus state is just this here. So let's plug it in. Minus a half I h bar minus. Take out the minus a half I h bar. Okay, and once again we end up with 0. Okay. The A, let's do now A minus plus. So the A minus plus, there's no prizes for that one. You can probably guess what that'll be. But apologies if I've done a mistake here. This should actually be plus. Okay, it should be plus, right? So two states, two corresponding states, you get 1. Two corresponding states, the inner product. So you get minus a half I h bar. Okay, and similarly here, you'll find that you get, so going through the same process, you get a half I h bar. And A minus minus, which I'm not going to do as well. It's a straightforward process, the same idea, you'll get 0. So now we've got the 4 components of the matrix, we've calculated it. So we can therefore write operator A as follows. So A plus plus, A plus minus, A minus plus, A minus minus can be rewritten as 0 minus half I h bar, half I h bar, 0. And if you really want to make it a bit neater, you can factor out the half I h bar and you'll get 0 minus I 0. Oops, it should be I half h bar. You get this. And just to note, kets are usually written as column vectors in quantum mechanics, and bras are written as row vectors, okay? So something like this is called a column vector, right? Whereas a bra is usually written as this. Just an example. Okay, this is called a row vector, okay, because it's along a row. This is called a column vector. And they come in very handy when doing calculations.